So I will the acronym means totally different things. I think. So, and it was, and I didn't know, so this was my fault when I picked it. But MOPS is too nice for Italian people to not
I will try to install your work in our lab when we do the reporting, etc. So, yeah.
So I will present 3 studies on cities that we did in the last couple of years. They are mainly done with my group in FBK, but also involving some collaborators in MIT and some people with Datapop Alliance. That is an organization that does use big data and computational social science to solve some societal challenges around the world, in particular in the developing countries. So we were interested in looking at city in a different way on what people like Betancourt, Geoffrey West did in the past, where they found really these interesting things of the systematic acceleration of urban life. That's very interesting and positive outcome, like if you have growth in the population, you have super scaling growth also in the human interaction and social interaction, and also in positive output like GDP, wage, patent. But at the same time, you have issues like violent crime, contagious disease, and pollution. So what we were trying to do in our work was taking different sources of data, what usually social scientists does, but having an approach that is more close to what usually urban scientists and social scientists done studying cities. So the first study that we did, our goal was understanding and try to understand why some cities are alive and others are less. Like the example I'm reporting here is contrasting New York and Detroit. And we started from a theory that was around for a while in urban science. That is this theory of James Jacobs that wrote a book in the 60s called The Death and Life of Great American Cities. This was one of the most influential books in city planning. So there are cities like Melbourne or Toronto that are based on some of the ideas of this book. And on the other side, so was a book that was never tested and was based only on observation and ethnographic studies. So James Jacobs was an activist, was not a scientist. He was writing the book to avoid to destroy Greenwich Village. So this is the reason, because still we have Greenwich Village. Because at the time there was the idea of having a total renewal, having a skyscraper, and do not have any more Greenwich Village. So the kind of things that she did is that she wrote a book where she said that the perfect neighborhood is Greenwich Village. So it's the neighborhood that has the characteristics of Greenwich Village. And in particular, so she defined a reason for the death and a reason for the life of the cities. And this is mainly related to the pedestrian activity. So you have a good neighborhood and a good livable neighborhood when you have pedestrian activity all over the day, while you don't have when you have instead some places that have only a type of usage, and at some point of the day they are empty or not used by the people. So she defines some conditions so that are based on things important for urban planning, like the land use, the dimension, the size of the block, the age of the building, and the density of population and an employed population. So density type of condition is the one that is more close to the result, for example, of Betancourt and Geoffrey West. So the city works well when you have a lot of people living and working there. But the other things are really related to how the city is built and done. And so, for example, the land use, you need to have two primary use at the same time for each of your district and neighborhood, because this make it possible having people that came in the place all over the day, and you have a sort of control of the place, like this phenomenon of eyes on street. So you decrease crime because you have a community that control the place, and you have also a place that has no period of the day or situation where it's empty or not used. At the same time, so you need to have small blocks in order to improve the workability and improve the possibility and likelihood of having face-to-face interaction. The third condition is related to the type of building you have, so you need to mix the building, and this has a sort of effect on the economic of the neighborhood, because at the same time you may have very big enterprise in the neighborhood, but also new and small economic activities. And you can mix also the type of resident. You can have not segregation, but a mix of low-income resident and high-income resident. And the fourth type of condition is related to the density. So concentration of people, concentration of enterprise, of people working in the area. These are all necessary conditions, or which we call diversity condition. And also we consider an additional one, that was the role of a specific place in the urban space, that are the vacuums. Like, for example, the parks are an example of vacuums. And they can have a sort of opposite effect. So sometimes they can be good because they are a way to increase the pedestrian activity, but also they can be, if they are not well maintained, exposed to criminality and privation and so on. What we did is that, this was never done before, we operationalized this condition. So we make metrics from this condition. For example, so I'm giving here an example for each of the conditions, but we compute more metrics for each of the conditions. So in this case, for example, we compute the mix of the land use, and the type of effect that we were considering is that if the mixing is higher, the better it is in the term of James Jacobs. Again, here we are considering the dimension of the block. So we are taking from OpenStreetMap the street intersection as a proxy for small blocks and then people interaction. So for each district we count the number of interaction given the area. And again, so in the James Jacobs idea, higher is the number of the street interaction, better it is for the vitality of the neighborhood. Then we consider the age buildings. Age buildings is a proxy for new and small enterprise. So if you have old buildings, you may have also small enterprise, and not only new enterprise that can arrange the higher end of the new buildings. And for having this proxy, we count the number of employees given the set of company to understand. So if we have only small, or also mixing of small and big company and enterprise in a place. Then we rationalize the density, that is the employment density and the population density, so population given the area and employed people given the area. And also we consider the role of these vacuums. For example, we count with OpenStreetMap the distance of the highway from a given district, and also the distance of place like a train station and other places. So our goal was, we have this condition, we want to predict the vitality of a neighborhood, and to have the vitality of the neighborhood, we use the mobile phone data, so we use CDR. In particular, we use the mobile phone internet activity as a proxy of urban vitality, so we compute the activity density in each district for the different hours of the day. We did for 6 Italian cities. We took the big Italian cities, so the one with more than 100,000 inhabitants, and we take a 6-month period of time. So for example, this is the map of Milan, where you have more people in the historical center of Milan. And what we found is that, so the The theory is valid, so this was never really tested in this way. So we can, from the metrics, predict with an R-square of 0.77 the urban vitality. And also we found which are the factors that count. For example, count a lot the employment density, count the intersection density, so how much big is the block of the place, of the city, and also the type of, and also the distance to specific vacuum, like for example small parks, highway, and so on. We found also some differences that, so for the Italian situation, they didn't show up like it was for the American case. So there is no role of the age buildings in the prediction of the urban vitality. This is maybe due to the fact that the diversity and the range of age of buildings in Italy is significantly different compared to the United States. So why this matters? So we find a way to evaluate the district vitality for several cities. We can use it. So for example, we can use it to quantify intervention and to try to have urban planning intervention that make change in the city in order to enforce this kind of vitality. That means spending time and ending out time in the neighborhood. The second study that we did was done with Cesar. So we move on another, with Cesar et al. In MIT, so we move to another aspect of the city. It is how the city appears. So not how they are built, so which is the urban fabric of the city, but which are the visual quality of a city and of a state. So we take the data that he collects around the world with several cities with a project called Place Pulse, and so he collects for each of the city on several streets from Google Street View images. He collects pairs of images and he asks to people with a crowdsourcing system to label, to rank which is the safer, the more boring, the more beauty, and so on. We focus only on the safety perception, and so what we did is again that we start from some theories. So one of the theories, the one that became famous in the 90s, particularly with the administration in New York, the broken windows theory. That so if you have city mismanagement, you may have also a push to some sort of misbehavior, and then you have a rise also on the crime, not only on the unsafety perception, but also on the real crime. And the other two theories were again the Jane Jacobs and the Oscar Newman, so where you have some characteristic of the building that have an effect on the type of behavior you have in place. So for example, so if you have street-facing windows, you reduce the possibility of crime or some kind of behavior because you have a sense of control in the area. Or another aspect that counts is the physical demarcation between the private and the public, like the stairs that you have in some building in the United States. So in this case, our goal was starting from the visual attribute of a street and of a place, a neighborhood, and predict the vitality and the liveliness of the city. So which are the people that are spending time in that street, which characteristics they have, and if they are influenced by the safety perception of the place. So we use for the safety perception the Google Street View images, and we use as a proxy again of the vitality and liveliness the mobile phone data. So the first things that we did was a computer vision type of work. So we have data for New York and Boston in the Place Pulse, the first edition of the Place Pulse. And we have some data for Rome and Milan, but they were very sparse. So we have only 1,000 of examples. They were really sparse in terms of street and in terms of both that we have for the safety perception. So the things that we did is that we train a convolutional neural network, and using place 205, that is a dataset from MIT, from Torralba, and then we transfer the data on place pulse, trying to have a sort of data augmentation. So we know some labels and score for some of the street. We want the score for all the street in Rome and all the street in so this is the result of our model. So the prediction from New York to New York is with an accuracy of 71%, and this is the comparison with the state of the art, that is the work done by Tamara Beck.
So these are the results of an out-sample test, or
yeah, this is the result that, so we take New York images and we predict again on New York with cross-validation. And the same we did Boston and Boston, then we train on New York and we predict on Boston, we train on Boston and we predict on New York. And this was for understanding how much good was our model, and then to do the same for Milan and Rome. So start from a very small amount of images that were 6.7, around 6 per square kilometer, and we want to arrive at 100 images, and we want also to have a degree, so a view that is the 360 degree view of the street. So we want to really know all the street and not some part of the street. Then we aggregate, so we aggregate using, because at the end the kind of information that count for us is a sort of safety perception score for each census area. So we aggregate using the average. You can aggregate, and also we aggregate in our experiment using the sort of majority voting, so which was the vote that counts more in terms of safety perception. So this is the safety score that we obtain for Rome, that is on the left, and for Milan on the right. So the yellow one is the more unsafe, and the darker one is the more safe.
So
in terms of perception.
The white things is because you don't have data, or
sorry?
The white spots is you don't have data, or
the white spots I think are related to.
So for sure there is people there. You know?
Yeah. Yeah, I don't know if it is due to the, for example, so this is due to the definition of the metropolitan city of Milan. So this part is not part of the metropolitan city of Milan. I don't know if for Rome this part
that you have
should
that
be.
wide island close to Pianola.
Yeah, this is a little bit.
Okay.
No, because the Vatican
No,
should
but
be in
the
the
city should be
in the center. So this is quite big.
That's why. Yeah. And one more thing. So this is all from the neural network.
Yeah.
Inference.
Yeah.
That's okay.
Yeah. And then the thing that we did was similar to what we did in the other work, but in this case we have not the internet activity like in the previous one. We have the code, so more sparse event, but on the other side we have socio-demographic information. So we know the activity broken down by gender and age. So we know how many, so which is the call density in a given area given a given age range or a given gender. So how many male, how many female, and so on. Again, we use for Rome and Milan, and for a time span of 3 months. So given that we have this socio-demographic information, we can have metrics like the people around in a district, so the general ambient population, but also the fraction of female and the fraction of male around in space, and the fraction of people below 30 and below 50 in space. So then we did a simple regression where we control for several other confounding variable, like for example, we consider the population density, we consider the distance to the center, because these are things that can have an effect on the vitality of a place. But our interest is which is the role played by the perceived safety. So this is the things that we want to understand if it has any kind of effect in the type of behavior and in the type of people you have in the place. It's a spatial regression for controlling for spatial autocorrelation. And we did several tasks. So the first one was predicting the presence of people, so the general ambient population. Then looking which is the fraction of women and young people. And then the third one is more related to the deep learning part. So we obscure some part of the images and we show which are the visual characteristics and the patches of the images that count to change the prediction of safety for the neural network. So if we look at the presence of people, so you know that there are several factors that count, for example, the population density, the employee density, so you have more people where you have more people living there and more people working there, but there is a role also of the safety appearance. And this became more important when you look at the presence of women. For example, there is no role of the number of women that reside in a place in predicting the number of women that are around in a place, but there is a role of the safety perception. So if a place is perceived as more safe, there are more women around that one will expect from the census. And in the same, in the opposite direction, you have for the young people. So if a place is perceived as more unsafe, you have more young people around. The other things was looking at these elements, visual elements, and what we found is that so if you obscure some of patches of the images, you have that there are characteristics that are related to the urban science, like for example the street-facing windows that count in the prediction of the neural network. So when you have these visual elements in the neural network, these rise the score of the safety perception. So the final project that I want to show, it's a project that we finalized some months ago, so was done with Marta Gonzalez, and we try to understand not only to predict crime, but to understand which are the factors that can describe crime in several cities around the world. So we started looking at what usually the social scientist does, that is the socioeconomic characteristics of the neighborhood. Then we look at what we did, for example, with the first work I showed today to you, that is the Jane Jacobs theory in the role of the built environment. And the third thing was the role of the mobility, so both the ambient population and the flow between the neighborhood, and how much connected are the neighborhood with each other. So the socioeconomic conditions, so the theory that is around since 30 years is the theory of Robert Sampson that consider the crime as a result of lack of trust. And so there are aspects like economic deprivation, ethnic heterogeneity, or residential instability that are factors that can induce higher crime in a place. And so what we did in our work was having this feature that we have for several cities. We have for Boston, Los Angeles, Chicago, and Bogota. Also different cities each other, and we predict the number of crime in a district using in the first model only the socioeconomic condition, plus we consider the spatial autocorrelation to avoid the fact that so close neighborhoods are close also in terms of effect in the outcome like what we found is that so if you look at the social disorganization and you take some of the variables that usually count, so the social disadvantage, the ethnic mix, in the residential stability, you can see that, so for some, for example, for Chicago, some of, so these conditions are quite well aligned with the theory. So where you have more social disadvantage, you have more crime. Where you have more ethnic mix, you have more crime. Where you have more residential stability, you have lower crime. But this doesn't work, for example, for Los Angeles. We have some, in some sense, strange insight where so social disadvantage seems not correlated or not associated with the crime level. The residential stability has instead a role that is aligned with the theory. Again, so if we look at Bogota or Boston, so we have some of the things that work aligned, but for example, in Bogota, the residential stability doesn't follow the theory or the work of Samson and other people said until now. So what it came out is that the social disorganization seems to be not enough as an only type of factor to understand the crime, or to have something that worked for all the city. And the other things that we did was taking the built environment, so taking this theory of Jane Jacobs and the idea that you have eyes on street control, so the informal surveillance, so the guardianship done by the ordinary citizen that control the community. And we extracted the same condition that I defined to you before, so the land use mix, the small blocks, age building and density. And again, so we have a regression where we want to predict the number of crime in the district. What we found is that, for example, if you look at the model that is based on the social disorganization and the model that is based on the built environment, the model on the built environment works better for all the three cities compared with the social disorganization. So this is the mean absolute error. So if you have lower numbers, better the model. And so what you have is that, so if you add the two things, at least for Bogota and Boston, you have an improvement in the prediction of the number of crime. But again, also looking only at the place is not enough, because so you have a very different place. So if you consider one of the variable that we are considering, and it is based on this.
Sorry, just one question.
Yeah.
If you go to the previous slide, because the maximum absolute is something that is interesting if we know what is the baseline, but so in terms of percentage error, what are we meaning? So how much is predictive this kind of approach? So 10%, 20% maximum error. So what? Because 374 doesn't.
So in terms of accuracy,
it doesn't ring a bell, you know.
No, so in terms of accuracy, so are all around the 70% of accuracy. So if you count the accuracy. So in this case, our interest was really contrasting how much you can reduce using the different model, and also showing that so at the end you don't have a sort of. So if you use all the factor, you reduce, but you don't have a sort of recipe that works for all the city. So this is a little bit the message that we want. And so for example, in this case, so if you consider the street intersection and the size of the block, this works very well for some of the city, like in Boston, or when we did also for some Italian city, works well for Milan, for Rome, doesn't work for Naples, doesn't work for Pavia. Because usually when you count the street intersection, what you are getting as a proxy in Bogota is a proxy for slum, and not a proxy for fancy historical center or residential places like Beacon Hill in Boston. So it seems that the sort of recipe that was things from the urban point of view works sometimes, but not always. This makes also sense. So there is no reason to think that having a higher sense of community is the only factor that reduces crime, because there is no sense to assume that in Islam you have a lower sense of community. Maybe you have a different type of considering the sense of community, but not a lower. And so the other condition that we had was the mobility. So looking, for example, at the connection between the neighborhood, because the idea is that so you have, if you have isolated neighborhood, you and you have disadvantaged neighborhood, these are the neighborhoods where usually you have a rise of crime, and also from the ambient population you can have a proxy of the real amount of people that are in the place, and this means a way to understand which are the potential victims or the potential guardians of a place. So the things that we did was using mobile phone data. We count two things. One is the origin-destination network and matrices, so the flow of the people between the different census areas of the different cities. And we have another metric that is the ambient population, so how much population you have in the different areas in a place. And again, so we use the Bayesian Poisson model, and in this case, the results are better for Boston and Los Angeles, but not for Bogota, using the mobility. If we add and we have the full model, so we have place, people, and the dynamics of the mobility of the people, we have the best model. So all the factors seems to count. And so there are some reasons that are also some sort of practical reason, because so in the case of the socioeconomic characteristic, you have really precise data with some of the census, but usually are not updated a lot. While with the built environment, you have something that is more updated, because we are using OpenStreetMap and other information for sure than the census. But on the other side, you may have some bias, for example, so the bias of getting this information are not really uniform on the difference. And then you have the mobility that describe really the population, but you may have problem to get this sort of. The things that really count here is that, so what we found is that, so you don't have a sort of recipe that in terms of crime can work for all the cities. So there is no a perfect way of a perfect set of factors that is associated with the different city and has a role in reducing crime. So this is really dependent from the culture. So on one side, so the interesting thing is that you need all this information to describe the crime, but on the other side, so you need also to consider that city by city, you may have opposite effect of same type of condition. Like one of the most clear example is the urban fabric type of things. So some type of way of building a city works for some culture and some community, doesn't work for other culture. So,
questions, please. Well, let's break the ice with the first one. So this is, all the last part about predicting crimes is or inferring crime. I don't. How is different from all the other things that are, the various POLNet, predictive crime algorithms, etc. So what is the difference between those approaches that are now also used by law enforcement and these kind of approaches?
Yeah, that in our case, so the interest was not really predicting or having strong performance in predicting. Our goal was more close to what Robert Sampson or other sociologists does, that was understanding which are the factors that count. So what the usually pred poll or other predictive crime algorithm does, they predict crime from past crime. That is the more simple way. So if you want an algorithm that predicts crime, predicting crime from historical crime data is the best way for doing this, because so the crime happens usually in the same place, so it's quite routinary. You have this hotspot type of phenomenon. So it's not something that is so difficult to predict when you look at the past. But so the kind of prediction they do doesn't explain anything on which are the factors that count. So which is the mixing of the type of people or businesses that you need to decrease the crime, which is the type of connection or road infrastructure that you need to build. So for example, we are now working with this project for the entire Colombia together with MIT to try to understand which kind of intervention you can do to decrease the crime in some of the city. And some of the interventions were already done. For example, Medellin decreased the crime, changing the network of connection between the neighborhoods. So one of the things that was more useful to decrease the crime was building this sort of electric stir, or also the other kind of connection between isolated neighborhood and the downtown. So this changed totally the way how was affected the mobility of the people living in this slum. Because, for example, when you have rain or these kind of things, these people cannot work. So usually they were unemployed. With this type of connection, they can go to work. And the other things, tourists can go in the neighborhood. So this changed totally. So changing it with simple way, the connection and the edges between the neighborhood change a lot the crime level.
In a sense, you are going toward long-range predictions that are really related to the fabric of the city, while the other kind of crime predictions are more the historical, few weeks things and that.
Yeah.
Questions?
So, in your first part, you use the mobile phone internet use as a proxy for liveliness, right? So, it depends on the area that in the daytime, in the more downtown areas where there are more high-rise buildings and like office buildings, you would have more usage of internet. And in the nighttime, you have more usage in the suburban areas. Do you have any variable that would explain, that would incorporate that part in the regulation? Or?
Yeah, so we use as a proxy that has all the classical problem of the proxy. So we decided to use the internet activity instead of using the call, for example. Like we were forced to use the call for the other study. Because it's the less biased type of proxy. So the other information, like I don't know, the traditional CDR based on call events or based on text messages now are very rare in some part of the city. So you can really track people only when they do the events, and these events are very rare. For sure we have the bias, and you have the effect that yes, in the night usually you get more activity maybe in the residential. But one of the things is that the internet activity has these things that there is now a large amount of people that check up and check email in a continuous way, and so it's the best way for really getting information about the mobility of the people. So it's better than, so if you use like it was in the past, in the first work, or not an equal work or this kind of thing, you use only the call, Now you have really a number of events that is very rare, and so you get few information about the mobility or the presence of people in a place.
One more question is about, those are all topics that seems very much related with policy making at the end of the city. So do you have experience, or were you able to, percolate those kind of information to policymakers? So what is your experience about that? All these studies about the city, and there is now a very large amount of work on this with new novel digital data streams, etc. Is being heard at the level of policy making in urban planning or not? So what is your experience?
So we have some running project with policymakers. So for example, the Colombia one that is with the Inter-American Development Bank and is with the government of Colombia, has the role in a couple of years to understand which are the factor, and so it's more directive. So we are working with the police, but the sort of final outcome should go to the policymakers, so to the major, or to the vice presidents of Colombia. And the idea is to try to find insight. In particular, they are very interested, and they are pushing us to find insight that they can change. So it's the interest is, for example, which is the role of some type of third places in the crime, in crime rising or lowering crime, which is the role of some type of events, because these are the things that can change. It's more easy to change the type of third places and businesses you have than, for example, redoing the city from scratch in terms of street or whatever. We are also doing some work, for example, with Rome. We're starting now with the administration of Rome to understand which is, for example, the role of culture, so cultural events, to mixing people. So the goal that they have in mind at the end is understanding which are the sort of cultural event and where they need to happen to reduce the segregation in the city, so to force some of the people from some a rich neighborhood in Rome to spend time in more low-income neighborhood. But yeah, so then yes, working on these things are really slow process, and then so you provide some insight, but you never really. At the moment, I never see really sort of impact that they are really using to take policy decisions. The other thing is that usually when you work with them, the initial things they have in mind is always the same type of dashboard to see and look at something, but they have a little bit less clear how you can design policy and intervention to force and change some sort of idea.
Okay, thank you very much again.